We should now know how to simplify, add, subtract, multiply, and divide rational expressions. In this lesson, we'll learn how to solve rational equations. Now, a rational equation is an equation containing one or more rational expressions. And this process for solving rational equations is very similar to the process of solving an equation that contains fractions, by first multiplying both sides of the equation by the least common denominator. We sometimes call this technique clearing the fraction. So let's remember how to clear fractions. If we have this equation that contains multiple fractions, we multiply both sides of the equation by the least common denominator of 3, 2, and 4, which would be 12. And when we distribute that 12 to all of the terms, we'll eliminate all of our fractions. So to do that, remember, you distribute it, first divide the 12 by the denominator, and then multiply it by the numerator. So 12 divided by 3 is 4, times 2 is 8x. 12 divided by 2 is 6, times 1 is 6. 12 divided by 4 is 3, times 5 is 15x. And 12 times negative 10 is minus 120. And now we just have a linear equation that we can solve. We subtract 8x from both sides. So we get 6 equals 7x minus 120. Then we can add 120 to both sides. So 126 equals 7x. We then divide each side by 7, so we get our answer of x equals 18. Let's apply this now to our rational equations, but let's first review our steps. To solve rational equations, the first thing you need to do is to list all of your restrictions. Numbers that make a denominator equals 0 can never be solutions, so we'll want to make sure that we do that. And remember, we talked about restrictions in lesson 1 of this unit. Then we clear the fractions, we solve the equation that results from it, and then we write our solution sets, but always checking to make sure that we didn't have an answer that's a solution, that's a restriction. So let's do 2 examples. Here is an example of a rational equation, x plus 6 over x equals negative 5. The first thing we should do is list what our restriction. In other words, what could x never equal? And in this example, x could never equal 0, because if I put 0 in for that denominator, I'd get a fraction that was undefined. And so I can't have that, so 0 is my restriction, and now I can clear my fraction. So I'll multiply the left side of the equation and the right side of the equation by x, because that will get rid of my fractions and my denominators. So now let's distribute it. X times x is x squared. X times 6 over x, well, my x's cancel, leaving me with just plus 6. And then x times negative 5 is negative 5x. What we got here is a quadratic equation. So to solve this quadratic equation, let's set our expression equal to 0 by adding the 5x to the other side. Write it in descending order. X squared plus 5x plus 6 equals 0. And now we want to factor and use the principle of zero product. So if we factor this trinomial, we get x plus 2 and x plus 3. And so our solutions have to be negative 2, because that would make 0 in the binomial, and our other solution must be negative 3. So these are our solutions, negative 2 and negative 3. And you'll notice that before we finish, let's check to make sure that neither of them are restricted. So since 0 is the only restriction, both of these solutions could work. Let's do one more example. In this example, I have x plus 2 in my denominator, so let's begin by stating our restrictions. X can never equal negative 2, because if x equals negative 2, these two fractions would become undefined. And so We know that negative 2 is our restriction. And now let's attempt to solve it. We begin by clearing our fractions. And in this case, we would need to multiply the entire expression by x plus 2. We do that on both sides. So now let's distribute that x plus 2 to each term. X plus 2 times 1 is x plus 2. Carry on our plus sign. When we do x plus 2 and you divide it by x plus 2, those two binomials cancel out, which leaves you with just the numerator of 3x. And the same thing happens here. Our x plus 2's cancel, leaving us with minus 6. Now let's combine our like terms, and we'll see we have a linear equation. So x plus 3x is 4x, plus 2 equals negative 6. And you solve linear equations by isolating the variable. So 4x equals negative 8, and divide by 4 and divide by 4, so x equals negative 2. Now before we write our solution set, let's check to make sure that our solution works. And what we find is that the solution that we got when we solved it is actually the value that is restricted. So negative 2 is not the solution, since negative 2 was a restriction. Therefore, there are no solutions that work for this, because the one solution we thought could work, negative 2, can't be a solution, so we would write no solution.